Hey guys, Mr. Betts here. In this topic, in topic 7.4, we're going to be using slope fields, which I talked about in section 7.3. And really, it's just looking at different types of problems and seeing what kinds of things we might try to do with slope fields. So I'm just going to go through a variety of examples that we might see with slope fields related to differential equations and talk about how we would work through those. So in this first example here, we have a differential equation and we don't have a slope field, but we want to know if we had a slope field for this differential equation, where would we expect to see slope lines that have zero slope, slope lines that have positive slope, slope lines that have negative slope. All right, so let's start with zero. Well, we're going to have zero slope where the derivative is equal to zero. So to get that, we're essentially just going to set it equal to zero. And so we should see slopes that are zero when x is equal to zero and when y minus 1 is equal to zero or y equals 1. So in a slope field, we would see slope lines that have horizontal slopes or horizontal slope lines where x is equal to zero. Whoops. Which is the y-axis. So we would see horizontal slopes along the y-axis. And then also where y equals 1, we would see horizontal slopes along there. So let me jot that down where x equals 0 and where y equals 1. Now, positive slopes, we're going to have to take a little bit more into account. We would expect to get positive slopes when, in this case, we're multiplying here, when the two numbers that we're multiplying together are either both positive or if they're both negative. So if we have a positive times a positive, we're going to get a positive slope. If we have a negative times a negative, we're going to get a positive slope. Now, in this particular example, the first factor, the 3x squared, can never be negative. So the only case that we have to consider is where they're both positive. So we're going to get positive slopes when y minus 1 is positive. Also when 3x squared is positive, but that's going to be for all x values besides when x equals 0. So that's going to be when y is greater than 1. So for any value in our slope field where y is greater than 1 and x is not equal to 0, because if x is equal to 0, you'll get 0 slopes. We're going to see positive slopes. So in this region here and in this region here, we expect to see positive slopes. Now, some might be steeper or less steep than others. We were not asked in this problem to actually create a slope field, but we would expect to see positive slopes in those regions. And then the last part is negative. As you might guess, it's just what's left. But negative slopes are going to be when we have a positive times a negative in this particular example, or a negative times a positive. And again, the 3x squared cannot be negative, so the only case to consider is a positive times a negative. So that's going to be when y minus 1 is less than 0, or when y is less than 1. Also, keep in mind that it's going to be when y is less than 1 and x is not equal to 0, because when x equals 0, we get 0 slopes. So we should see slope lines here that are negative. Now, this particular kind of question is not something that you would expect to see on any kind of assessment. However, it is a good strategy for matching up slope fields with differential equations. So if we can see a differential equation and know where to expect 0 slopes and know where to expect positive and negative, that will allow us to match up differential equations with slope fields a lot more easily. So in the second example, we're going to try to match up, in this case, functions with a slope field. So we want to know which of these functions could be a solution to the differential equation that created the slope field here. I actually went through a problem like this in topic 7.3, but I wanted to throw it in here also because it's relevant. So essentially what I want to do, especially with the functions that I know what they look like, is just try to picture if it could be a solution by picturing what it would look like going through the slope field. The cosine function is going to look something like that. And clearly we've got some points here where the slopes are not matching up. So the cosine function is not going to work. Y equals 1 minus x squared is a parabola that opens down. So actually it goes through 0, 1, it goes through -1, 0, and 1, 0. So we're going to get something that looks like this. And again, we have points here where the slopes are not matching up, so we can eliminate that option. Y equals e to the x looks like this. Definitely, I know I didn't do that real well. It goes up a little bit more, but definitely we should see positive slopes in our slope field there, and it's negative slopes, so we can eliminate that one. This one is not a function that you may recognize right off the bat, but it is x squared plus y squared equals 1. It's the unit circle, or at least the top half of the unit circle, because the square root gives us a positive value. So the y values are positive. And this one doesn't look terrible, but you can see here that the slopes are not quite right. So this is not going to work either. So we can eliminate that one. So by process of elimination, we're really down to E. If you think about what's going to happen with this graph, so first of all, if we think about an initial condition, we plug 0 in for x, we get 1 for y. So y of 0 is 1. So it's going to go through this point right here. Also, if you think about asymptotes, because slope fields are good at showing us asymptotes, as x is approaching infinity on this function, as x gets really big, the denominator is going to get really big and the function itself is going to approach 0. So we would expect that as we go to the right, we're approaching 0. The same thing's going to be true as we approach negative infinity. And so this slope field here looks like it is a good match for this function. So we're going to choose that as our answer. In this example, we have a slope field and we want to answer a question about limits. And these limits are related to horizontal asymptotes. So remember, we get horizontal asymptotes if a limit as x approaches infinity or x approaches negative infinity is some finite number, then we get a horizontal asymptote. So in the first part here, we have f of 0 equals 0. So we know that this point is going to be on the solution, and we want to know what happens as x goes off to the right. So as x gets really big and approaches infinity, just following the slope field, it looks like it's going to look something like this. And these horizontal slope lines here are going to be lines where our function cannot pass, because if the function would ever get to one of these horizontal lines, then it would just become a horizontal line, which is not a problem going to the right, but going back to the left to get to our initial condition, we can never get off of it. So we could never start at a point here and break off and get down to our initial condition, because we would get a slope that doesn't match here. So that is going to be a horizontal asymptote going to the right. And so that is at y equals 3. So this is going to be 3. I didn't really give enough room to write my answers, but you get the idea. If f of 0 is 4, and this is our initial condition, if we draw that solution, it looks like the same thing's happening. We're just approaching that y equals 3 from above instead of from below. If f of 0 is 0 and we're going to the left, so x is approaching negative infinity, we can follow our slope lines here, and looks like we've got a horizontal asymptote at y equals -4. And if f of 0 is 4 and we start here, I know there's not a lot of information above this, but it looks like we're going off the graph, and it looks like as we get higher, it's getting steeper and steeper. Now, we don't know that we're not going to have something leveling off here, but it does appear that based on what we're given here, that this is actually going to approach infinity. Again, we can only answer based on the information that we have in the graph, so it's possible that that's not, but based on the graph, it looks like that's going to be our answer. In this example, we have a slope field, and we want to know which differential equation may have created that slope field. So this is a good example of one where we want to look at where there's positive slopes, where there's negative slopes, where there's 0 slopes, and see which ones are going to match up. My eye jumps straight to part E here. If the differential equation is dy dx equals sine of x, when x is 0, we should see 0 slopes, so anywhere along the x-axis, which is true. But also we should get 0 when x is pi over 2, which is about 1.5. And around 1.5, we're not getting 0 slopes here. So sine is not going to be a good option. We would expect to see slope lines for this graph that would be a wave like the sine wave is. Okay, so that's not a good option. If we look at other choices here, I'm going to go with B here. I'm going to kind of jump around. We would expect 0 slopes, so dy dx is going to equal 0 when x is equal to y. And when x is equal to y, we should see 0 slopes, so that should be along this line right here. We're not seeing 0 slopes for most of those. It may be 0 here, but everywhere else it's not 0, so that's one that we can eliminate. So seeing where the slopes should be 0 is a good way to help us out here. It looks to me like we are getting 0 slopes along the y-axis. Now that also looks like it could be tick marks, but I noticed that they don't have tick marks on the halves on the x-axis, so these tick marks in between are probably slope lines. So when x equals 0, we should get 0 slopes, which the 3 remaining options all give us that. If we look at where we should get positive or negative slopes, in the first quadrant here, notice that all of the slopes are negative. So in the first quadrant, x is positive and y is positive. And so when x and y are both positive, we should get negative slopes. And that is going to happen here and here, but it's not going to happen here. If x is positive, y is positive, we should get positive slopes, so we can eliminate D. Seems like we're getting closer. Notice that the only difference between A and C is that A is divided by 1 plus x squared and C is not. So the sign of the slopes is going to be the same for both of these. So looking at 0 slopes, positive slopes, negative slopes have narrowed it down to 2, but now we've got to figure out how we're going to distinguish between these two. And to do that, what I'm going to do is just pick some values. If I pick the point, say 1, 1, looks to me like that slope is -1. So let's plug it into both and see what we get. So if I plug it in to A, so the slope at 1, 1 is going to be -2 times 1 times 1 is -2 over 1 plus 1, which is 2, and that's -1. So that's promising. If I look at C and do the same thing, we're going to get -2 times 1 times 1, which is -2. This slope line, this particular one right here, does not look to me like it has a slope of -2. So a slope of -2 would be going from this point to the point 2, -1. It should be going in this direction. And it's not. It's a negative slope, but it's not quite the same. Just based on that, I'm going to say A is our answer. For the sake of time, I'm going to move on, but it would be worthwhile to check more points. And there are some points where the differences are going to be more extreme. And so those points are going to be the ones that we'll want to look at. I do want to point out that the differences will be more extreme for bigger x values, because when we plug in a big x value, we're going to be dividing by a big number, and we'll get smaller slopes with this than we will with this. Okay, this is the last example. Now, on a typical AP multiple choice question, you're only going to have 4 options. I wanted to throw a bunch on here so we could talk about a few things. So we have a differential equation given to us here. So dy dx is equal to x times y minus 1, which could be the slope field for that differential equation. So what I'm going to do here is I'm going to start with where the slopes should be 0 and see if we're getting that for these. So we should get 0 slopes where x equals 0. All right, so if we look at where x equals 0, that's going to be along the y-axis. We don't have 0 slopes here. So that one's gone. We do have zero slopes here, so we can't eliminate that. We do have zero slopes here, so we can't eliminate that. Some of the slopes here are zero, but most are not, so we can eliminate that one. This one looks okay. This one looks okay. This one looks okay. And this one does not look okay. So knowing that the slope should be zero whenever x is zero, we can eliminate 3 out of the 8 options. Now, if we do the same thing for y, we should also get zero slopes where y equals 1. So that's going to be here, which we can eliminate that one. We do have zero slopes for that one and that one, not this one. So we can eliminate that. And we do have zero slopes for this one. So knowing where the slope should be zero, we've been able to eliminate over half of the options. If this were an AP test with only 4 options, we're down to 1. Unfortunately, we still have 3 left. So what I want to look at now is where slopes should be positive or negative. So I'll start with positive. So we should have positive slopes when 2 different cases now. When x is positive and y minus 1 is positive, so that's going to be x greater than 0 and y greater than 1. Okay, so this is going to be to the right of the y-axis and above y equals 1. So in this region right here, we should see positive slopes. And indeed for this one, it looks like we do, so we're okay there. Here we should see positive slopes, and we do not, so we can eliminate that one. Here we should see positive slopes, and we do, so we cannot eliminate that one. So for positive slopes, at least one of the cases, we're down to 2. We should also see positive slopes if x is negative and y is less than 1. Okay, so that's going to be to the left of the y-axis and below y equals 1. So positive slopes here, we do not. Positive slopes here, we do. And so we are down to our answer. That is exciting. I'm sure you're as excited as I am to wrap that one up.